Let's check these and we can go over number 2 together. We'll reveal the answer as we kind of go. So check out numbers 1, 3, and 4. Number 1, 4n minus 9 is less than or equal to 2. Number 3, 4x y to the 4th root 3x. Number 4, simplified completely, I believe would be 16 x to the 14th over y to the 6th. Okay, so I realize we haven't done number 2 yet, but numbers 1, 3, and 4. Any questions, comments, concerns, anything I can do to help out? Number 1 is really old, going back to like last September, I think. Number 3 goes back to like January. Number 4, a little more recent. Number 2 is like last November, I think. Okay, any questions on 1, 3, 4? Okay, so then let's take a look at number 2. This one says, Billy and Amy want to play at the park. Billy leaves their home before Amy and walks to the park at a rate of 5 feet per second. So obviously 5 feet per second would be an important thing to connect back to Billy's rate, Billy's speed. Amy leaves their home 90 seconds later, so Billy gets that head start, a 90-second head start to be exact. And she runs towards the park at a rate of 8 feet per second. So I'm trying to mark the question up here a little bit, point out the things that are important to me, try to make those good connections. After how many seconds will Amy catch Billy? It does say show the algebraic steps leading to your answer and round, if applicable, to the nearest tenth of a second. Okay, so do you guys draw a picture? I would suggest it, really would, especially a word problem like this, Billy and Amy walking, running, the park, all that stuff. So I'm going to say that this line represents their house. This line right here represents the park. And let's see here. Billy gets a good-sized head start, doesn't he? Before we start paying attention to Amy running after him, he gets quite a bit of a head start. So I'm going to say that Billy, he starts out here somewhere. I'm going to call this the distance of Billy because he started off. And how big of a head start does he get? 90 seconds, but as far as distance goes, like how much distance? Say again? 450 feet, right? Because he had 90 seconds before Amy even got going, right? So for 90 seconds, she sat there and he's walking to the park. So 5 times 90, 450 feet. Okay, so I'll put 450 right there. So that makes sense? Any questions? Okay, so then Amy doesn't get the benefit of this head start. So she is starting back at the house. And I don't know, does she catch him at the park? Maybe does she catch him before the park? I didn't tell you how far away the park was, to be honest with you. But she catches him somewhere on the way to the park, right? That's what's implied here. I'm going to call this the distance of Amy. Still making sense? Okay, so the hard part about these questions isn't necessarily the picture. It's taking the picture and writing an equation with all the stuff in the picture, and that equation has to be actually true. It can't just be made up stuff. It's got to be a relationship that actually is a legitimate relationship. So does anybody have any ideas? What could I do with all the stuff in my picture that would produce a true relationship between all of it? Any ideas? Colton.
We do 450 plus dB equals dA.
450 plus dB equals dA. Obviously, he's written a relationship. He's got the equal sign in there. That's good. Do you think this is true? And we're like, this is really weird. Like in a math class, how many times are you asked that question? Is the thing that somebody wrote true? Way too often, all we want to say is, did we get the right answer? Or did we write some stuff down? I'm just asking you, is it true? I'm hearing some yeses. Is 450 plus the distance? It is true, isn't it? It's the only way to make this true, is to add the 450 plus the dB to get equal to the dA. Okay, so then continuing on, distance is, as we know, rate times time. What is the rate of Billy? 5. So 450 plus, the rate is 5. What is Billy's, like how much time does Billy spend on that red distance? Well, we have no idea. So that's going to be our variable. So we're going to say 5t for distance of Billy. And distance of Amy could be rewritten as what? 8t, right? Her rate is 8, as we underlined before. And once again, from the time that she leaves the house to the time she catches up to Billy, we don't have a clue. So it'd be 8t, and it's the same time, right? She starts moving right when Billy hits that 450-foot head start. Okay, so we got this wonderful relationship here. All that we need to do now is try to solve for the t. So I would subtract 5t from both sides. That would give me 450 is equal to 3t. Dividing both sides by 3 would give me 150, I think. Is that right? Yeah, that's right. It's a Tuesday, but it feels like a Monday. Could be a little rusty. So I got 150 equals t. That would be the time, and that'd be in seconds, the time that it took for Amy to get out there to the same place and catch up to Billy. Okay, so what do you think? Saw a handful of folks had that. Others had like 56 point something. So if you got 56 point something, just know that there's like at least 8 or 9 of you that got that. Others got other things. Do you have anything you want to talk about there? Again, remember, math should make sense. If I've done something up there and you're looking at it, you're thinking, that is just illogical. It does not seem good. That does not seem true. Let's talk about it. You're not going to make me mad or sad or anything like that. That's kind of what math is. It should make sense. Hanging in there? Good? Yes? No? Okay. Fair enough. All right. So let's talk a little bit about your week. Your week is going to look like this. I'll write this out so you can see it and hear it. So bless you. Today we're going to be working on equations and factoring. We've been working on factoring for like 2.5 weeks now. We're going to just finish off with one more week, but we'll still be factoring after that as well. Factoring is a big deal. And then tomorrow. Tomorrow is Wednesday. Tomorrow we have our concept quiz 18. Okay, concept quiz 18. I'll give you one guess as to what the concept is. Factoring. Yes, we've been working on it for a long time. So tomorrow is going to be our first chance to show, yes, indeed, I do know how to factor. Or maybe I don't, but you know what? You get retries. So whatever. Or 18, it should be 16. It's 16. Sorry. I messed up the number. It's concept quiz 16. Is factoring. What messed me up is this. So this was in my mind. Thursday is DMR quiz 18, which is what you just practiced. Okay. Do you guys have any questions? Final thing then, next Monday, I believe we do actually have school next Monday, and we will be starting Unit 6. Unit 6. And so with that, we do have a new notes packet with examples and all sorts of wonderful things in there. And so if you would, make sure by next Monday you have printed out or notability'd or however it is you deal with it, your Unit 6 note packet. I'll remind you all week. Hopefully that'll be enough. Any questions on any of that? Okay, so I want to leave you with this last thing right here before we dive into some more factoring today. And it's this. The last unit test, the one we took, was it last week? Or was it the week before? Whenever that was. For many of you, that was like a revelation. You're like, oh, as a matter of fact, I am getting this. Yes, right? And I would just want to remind you that if we look at like kind of a graph of how this went, some of the early tries on the concept quizzes were very bad. They were down here somewhere, right? But as you started to do retries and try again, some of you took 2, 3, 4 retries on those, and it ended up paying off for you. You're like, okay, yes, I think I get it. Guess where you were when it came for test time? You were up there, weren't you? It was so awesome. It was so awesome. Instead of muddling around down here and saying, oh, I just don't get it, you tried and you tried and you tried. And there were some ups and downs and some bumps in the road along the way and all those things. But in the end, the test, it really paid off. You really showed, I do know what I'm doing. So that's awesome. I hope that you will take that same lesson to heart now, right? So, I don't know, it's like 3 weeks from now, we'll have another test, another unit test. And we have that, we still have that concept quiz 15.
So 16 is tomorrow.
16 is tomorrow. Yep. Concept quiz 15, it was on, darn it. It was on, I should go look this up. I'm having a Monday morning moment. Exponent rules, thank you very much, Joe. There's like 3 or 4 people that have already attempted a retry. That's great. You're better off starting those early rather than late. So I'd encourage you, this week, we got a business lunch today. It might be too late today, but we got a business lunch on Thursday and other opportunities. Please, please, please go back through, put some effort and some heart into your retry assignment, come back in, do a retry. Get that grade up to an A, show that you know what you're doing, and that'll help you down the road as well. So let me just encourage you to do that. Do it now, not in 2 weeks. Fair enough? Okay, cool. So I want to start you guys off with sort of hopefully a logical question. It's right here. And I'm just going to let you stew over this, hopefully for not too terribly long. But it's right here. If you guys would, think about this. If A times B equals 0, what must be true? If A times B equals 0. Go ahead. You're about to say something, I interrupted.
No.
Or Josh?
I was going to say either A or B has to be 0.
Okay, so either A or B has to be 0. What do you guys think of Josh's comment?
True.
Does it make sense? Again, remember, math should make sense. It's not this series of rules that some math teacher or math book just made up and you're like, well, I guess we'll just trust them. It really ought to make sense. So does Josh's idea make sense, really? A lot of you have said, yeah, it does. Anybody object and say, no, Josh, you're totally wrong, or you're mostly right. I want to be really rigorous about this, and I think that you're off by a little bit. I don't know. Any thoughts? Makes sense to everyone. In Josh, we trust, or in Josh makes sense at least, right? Okay. So he said, if A times B equals 0, then either A or B has to be 0. I'm going to put one little caveat in here. Or what? What else could we add on to this? Either A or B has to be 0, or
0.
Or what?
Or both are 0.
Or they're both 0. There we go. Or both A and B are 0. Yeah, so I think if we tag that onto the end there, let me be consistent here, then I think we've come to a place that hopefully makes a lot of sense, right? Because either A or B could be 0, or they're both 0. In either one of those scenarios, A times B would be 0. So this is really important. I know sometimes when we do math, and I get it. Sometimes when the number 0 pops up, we kind of panic a little bit, don't we? Have you ever been there? Like you're solving a system of equations, you're solving an equation, and you get this answer of x equals 0. Does your heart skip a beat and you're like, I don't know, no solution? Or I must have messed up. You know what I'm talking about? Did you know? If there was a Mount Rushmore of numbers, 0 would definitely be up there. It's one of the most important numbers. It shouldn't cause us to freak out. It is just a number, but it is an important number for sure. So can anybody explain why Josh's idea and then Noel's little extension onto that idea, why are these true? Why does this make sense? I'm going to say it like this. You said it pretty well. She said anything times 0, 0. I'm going to say any real number times 0 is 0. So we can get into some shaky territory if we say anything, because we can actually find some counterexamples to that. But that would be beyond the scope of this class. Okay? So if we said any real number times 0 equals 0, would you guys all agree with that? Yeah, that's why this works. So it doesn't work like if I said, think of it like this. If I said a times b equals 5, if I just told you, hey, I've got some expression a and some other one b, and I know that a times b equals 5, does that guarantee that either a is 5 or b is 5? It doesn't, because 5 doesn't hold that same property. What if it was a times b equals pi? Does that mean that a is pi or b is pi? No. This property only holds true for which number? 0. So, has anybody figured out what the ZFP, you see it right here? The zero factor property. Do you see if you figured out the connection here? ZFP stands for the zero factor property, meaning if a times b equals 0, then either a or b or both of them have to be 0. And we're talking specifically about the number 0, not any other number. This only works for 0. Believe it or not, sometimes I have some really advanced math students that sometimes mix this up, and they forget that it's all about 0 in this case, right? Any number times 0 is 0, not some other number. Okay, so we're going to use this zero factor property to help us solve quadratic equations. And so I thought maybe I'd take a minute and help us remember what a quadratic is. So does anybody know, anybody remember this from the last couple of weeks, what a quadratic is? It's got a very specific form. I like a times something.
A times x squared.
Ax squared.
Times x plus b times x plus c.
Okay, so this right here, that is a quadratic. Agreed with you there. If this is going to be a quadratic equation, this is how we normally present it. Equals 0. You might want to write that down. Ax squared plus bx plus c equals 0. This is an example of a quadratic equation. So an example using numbers would be something like this. Negative 3x squared plus 11x minus 7 equals 0. So that would be a lovely quadratic equation written in standard form. So standard form means descending order on the left equals 0 on the right. What do you think? Any questions? Maybe you've heard of some of this. A lot of little details. So let me give you an example of something that would be important to know. Is this, as I have currently written, is over here, is this a quadratic in standard form? Why?
Because the 7 is behind the equal sign.
And it should be the 7 where?
In front of the equal sign.
Okay, so how would we get that 7 where we want it?
Subtract it.
Subtract 7. And when I do that, it would be everything on the left side equals what?
0.
That's really important, right? Standard form, it's like our home base. We want everything on the left side in descending order equals 0. That's where we're going to start. And then we'll do stuff with it, but that's where we want to start. Okay? So I thought I would give you guys just a minute here to review what factoring looks like. And so if you would, take a look at this little exercise coming up here. There's 5 of them, it looks like. Which of the following, of the 5 there, which of the following is in factored form right now? So take a minute and, I don't know, next to each of those, write factored or not. Something like that. Okay? So next to all of those, indicate which of those you think is in factored form and which of those you think are not in factored form. So this is kind of a review from what we did last week as far as what factoring was. It's really key to identify when something is in factored form. Which of those do you think is factored right now? Which of those do you think is not? For those maybe are struggling a little bit, let's remind ourselves, what math operation always goes with factored form? Multiplication, right. So if you look at it and you realize, hey, overall, this is a multiplication problem. It's something times something, then that would indicate that it's been factored. But if you look at it and say, well, you know what, overall this is actually a sum, right? It's this plus this minus that. That would be not in factored. You want to be able to get to factored form if it's not. You want to be able to identify when it is, when it's not. All right, so what do you guys think? The very first one there, 5x squared plus x equals 0, is that factored form or not? The answer to that one is no, it is not. No. What about the one right next to it there? X parentheses 7x plus 4 equals 0, factored or not? Yes, factored. Yeah, very good. Do you all see how it's basically in its most fundamental place, it's a multiplication, right? It's x times this other thing. Like that's how you would describe it. What about the one on the far right up there? Factored or not? What is the one symbol that kind of ruins it as far as being in factored form? Yeah, the plus sign. If that plus sign was then it would be factored form, wouldn't it? But it's a plus, so it's not a multiplication problem. Yeah, it's just like rotate a little bit. If you got a little tired and just fell over. Yeah. All right, how about the lower left one? Factored form or not?
No.
Not factored form. In fact, you can see that it's addition and subtraction because you got something plus something minus something. It's not a multiplication problem. What about the last one, lower right? Factored or not? Yes, factored. Agreed with you there. It's a binomial times a binomial. It's been factored. Okay, so it's going to be really key that we would be able to identify when something has been factored or when something hasn't been factored. So that's going to tell us the times when we need to do the factoring ourselves or maybe the times when it's already been done for us. Okay. Any questions? All right, so then let's take a look at number 1. And I'm going to do this for you. I'm going to ask you one question. And then I'm going to, once we establish the answer to that question, I'm going to let you run with it. For number 1, whatever that expression is on the left, has it already been factored or do we need to do the factoring? It's in factored form. Just there was one like that earlier. That is in factored form. You've got something times something equals 0, don't you? So let's see if we can tie this back, and I'm going to let you guys try to wrestle through this. Let's tie this back to what we just talked about, that zero factor property like Josh and Noel helped us with. They said, if something times something is 0, then either one or both of those somethings have to equal 0. See if you can use that to help you solve this. I'll give you a couple minutes to try this, and if you get stuck, you get stuck. I'm not too worried about it. I'll show you. I'll help you. But I want you guys to explore and try compare. So I am going to eventually work my way back around to the right way to do this, but I am going to show you. I'm not going to call this the wrong way. I'm going to call this the long, I wish I would have seen this before way. Make sense?
Yes.
So please pay really close attention. What I'm about to show you is the incredibly long way. It doesn't need to be this way on this one. Check this out. Saw a lot of people do this. In your head, you said, oh, look, it's a binomial times a binomial. I know what to do with that. Here we go. 2x minus 5. So let me describe this person that did this. The person that did this knows a lot about algebra. They know a lot about multiplying binomials together, but they didn't really connect factored form with the zero factor property. They kind of went on autopilot, where you just you see something and you don't really read the instructions. You just kind of you just do something. It might not have been a terrible thing to do, but it wasn't really the thing you should have done. You multiply this out, you get 2x squared minus 5x plus 6x minus 15. We come down here, we realize those were like terms. We get to 2x squared plus x minus 15 equals 0. And then maybe you got stuck. I don't know. I mean, maybe you even did this. This is where we'd start to go into some bad territory. You know, maybe you did this. You're like, I want to get that x by itself.
Oh.
I don't even know what to do with this, you know? And you got like really stuck. I mean, there's some other stuff that could have happened there that could have gone into the really bad territory where we would just say, that wasn't just the long way, that was the wrong way. That was a bad thing, illogical to do that. And I'm not going to go into there. I don't even want to like put that in your minds. Let me just tell you right now, if you are solving, you want the expression to be in factored form. Would you guys agree with me that we did all this work right here? We got down to here, and we took something that was in factored form, and we turned into something that is not in factored form. Let me just be plain about this. With these quadratics, we really want them to be in factored form. We don't want them to be in non-factored form. And so if you get something like this where it's in factored form already, you're kind of being set up for success, and sometimes you shoot yourself in the foot, right? And you're like, oh my goodness, I just made this way more difficult. Because what you'd need to do here is you'd need to take this and factor it. And shockingly enough, the factoring for this would be that, if you just reverse the box thing, right? So that's what I mean by the long way, the one we'd rather avoid if we could. So let me just illustrate what we should do, what we probably would be a better choice. Please check this out. If, like you guys did, and you guys did a good job of this, if I recognize that right off the bat, this is in factored form, then here's all I have to do. I have to essentially say, well, really, isn't this just a different version of A times B equals 0? And let's use the thing that Josh and Noel suggested. If A times B equals 0, then doesn't that mean that either A is 0 or B is 0 or they're both 0? So check this out. Here's what you do. The step I'm about to show you, you got to show. Check it out. What if the first one was 0? Wouldn't that be what we would write? What if the second one was 0? Wouldn't we write something like this? Right? Remember, if A times B is 0, then either A or B or both are 0. So you're going to need to write one factor set equal to 0, the other factor set equal to 0. And then from there, you guys are really good at these. These are really easy to solve. The one on the right, you could just do it in your head, couldn't you? X equals -3. Just subtract that 3 on over. The one on the left, we'd have to go plus 5 to both sides. 2x equals 5, and you probably could have done this in your heads too. X is equal to 5 over 2, also known as 2.5. So you got two answers. Two different numbers work here, -3 or 2.5. Does that make sense? Again, that's the goal, right? That it would be logical, that you wouldn't look at it and say, well, the pattern, like I need to memorize the pattern. No, you don't. You need to understand the logic that gives the foundation for it. And once you understand the logic for it, then you can apply it to just about any of these situations. Yeah?
So you're saying that x can have two values then?
Remember what a solution is? A solution is a number or numbers that make the original equation true. I'm not going to take the time to do this right now, but I guarantee you if you took either one of these numbers and you plugged it back in for x, you would get a truth. So there's actually true. So there are equations, lots of them have 2 solutions. There are other equations that have 3 solutions. There are other equations that have 10 solutions. Others have infinitely many solutions. We're not going to go with all those necessarily, but we're not restricted to one number because some equations have more than one number that works. Yeah.
So you do only have to have one of those answers?
No, you have to have both.
You have to have both.
Yep. So when I'm saying solve, I'm saying basically show me all the numbers that work. There might be 1, there might be 2, there could be 3 or 4. You never know. Okay. Any other questions? These are good. Anything else? For a lot of you, this is all kind of new stuff, so it would make a lot of sense if you had a question. All right, well, so then let's take a look at number 2. I think we only have like 3. I got 3, 4 of these. Okay, number 2. So let me ask you a question. We'll do this in a stage or two here. I'm going to let you guys do a lot of exploring yourself. Question number 1 for this number 2 here. Question number 1. Is this in factored form right now? So your first task is to use all that factoring skill work that we did in the last couple of weeks and factor the left side. Okay? So, is it factored? Nope. Question is, can you get it to be factored? Give it a shot. Hopefully this will allow you to make some really good connections. Let me review the thought process. Number one, is it factored? And you all said no. So your first task is to get it factored. And I'm telling you right now, you are going to regret not looking for GCFs first. Your very first move should be, hey, is there something in common? So the way that we do that, I'm going to just draw a little 1x2 set of boxes. And I'm going to put my 12x squared right here, my minus 4x right there. And I'm going to try to factor from right to left and ask myself what's in common. So what numerical factor do they both have? Numerical, no, they have a bigger numerical factor than that. They both have a 4, right? Because 4 goes into 12. And 4 goes into 4. And do you see how they both have an x in common? Okay. So if I factor a 4x out of both, let's think about what's left over. For the first one, I had a 12, but I factored out a 4. What's left over? You're not listening. A 3. There we go. And it was an x squared, but we took an x out. So an x. There we go. I had a 4x, or a negative 4x, but I took the 4x out. What's left over? Yay, minus 1. There we go. So there's my factoring right there. So this would be 4x parentheses 3x minus 1 equals 0. So that 3x minus 1, do we need to go back and do one of those 2x2 boxes for 3x minus 1? We don't, right? It's just a linear factor. There's no. So those of you that immediately jumped in the 2x2, I would hesitate. That would be my second move potentially, or maybe in this case, the move that I don't even need to make. This is in factored form. It's in an easily solvable form. So can anybody tell us our next move? There's.
Well, because is it 4x and the same thing as a, and 3x minus 1 the same thing as
Yep, this is like our A. This is like our B.
So
So what do we do?
Test out. So if a equals 0, then it'd just be 3x minus 1 equals 0.
Whoa, no, you kind of ignored the 4x.
Yeah, because if a equals 0, one of the two is 0, so.
Okay, so, but you were the one that said they both could be 0, right?
True.
So we set both equal to 0.
Oh, first, okay.
Yeah, I'm going to immediately say 4x equals 0, 3x minus 1 equals 0. So guys, this step right here is key. Once you have factored, you're to that place where, hey, you got a times b equals 0. What you want to do is you want to set both factors. All the factors you got, you want to set them equal to 0. And then you solve. So for that first one, 4x equals 0, what does x have to be?
0.
Has to be 0, right? Divide both sides by 4, you can see it. And how about the other one? X equals what?
1/3.
Those, my friends, are your two answers. This step right here, I'll emphasize this again. That step that I drew the arrows at and put in the little box, that step has to be shown on your paper. Not in your head, not in your heart, not said. It needs to be written on your paper. I don't really care if you do the whole +1 to both sides, divided by 3 on both sides. At this stage of the game, I know you can do that. But I do want to see that you set each factor equal to 0. Okay, our class is going by fast. We have time for one more, and it's number 3. Number 3. So if you would, answer this question first before you tackle number 3. Is number 3 currently in factored form?
No.
So what's your first task? Factor it. Think about a GCF. And after you've done a GCF, consider a 2x2. Okay? Please look at number 3. That you quickly realize that the only GCF here is a 1. So we need to go 2x2 right away. Please don't pack up right now. It should be done here in about 2 minutes. That'll be just the right timing. So upper left corner is x squared, lower right is 18. You do your AC off to the side. AC was 18. So you run through all the numbers that you could, like 1 times 18. That doesn't work at all. 2 times 9, well, that's 11, so maybe it should be these two numbers, negative 2 and negative 9. So I go here and here with those two numbers. When I factor, I get x, I get negative 9, I get x, I get negative 2. So your complete factoring would look like this. X minus 9 times x minus 2 equals 0. And remember, this is the key step. This is the zero factor property step. Would tell us that x minus 9 has to equal 0 and or x minus 2 has to equal 0. So did you guys get x is equal to positive 9? X is equal to positive 2 for your two solutions? And the other question is this. Did you show that step? I hope you did. If so, you're in great shape. Have a wonderful day. See you tomorrow.